This is the soil moisture sensor we're going to use in our project, and this will be inserted inside the soil. And this measures the moisture content inside the soil and transmits that data wirelessly to our electronic main hub. This is the top view of our soil moisture sensor. Here we are using an Atmega 8 microcontroller chip, and these are the wires that are bringing the soil moisture analog data to the microcontroller. And this is our temperature sensor LM35, and this is the radio frequency wireless transmitter which works at 433 MHz. It sends the reading of the temperature and moisture sensor to the main electronic hub. This is our main controlling hub. It is controlled by the ST-Microelectronics board. It receives data wirelessly from the field, which is the readings of the temperature and moisture sensor. Accordingly, it supplies water to the fields. On our main controlling hub, here we have an on-off switch, and this is a LCD display, and here we have few buttons for controlling the whole system. Moisture and temperature sensor data collected from the field is analyzed by the STM-Nucleo board, and accordingly the required amount of water is supplied to the field through this water pump. This water pump is controlled by an electromechanical relay installed inside our main hub. Now I'm going to show a live demonstration of this project. Okay, now I'm just turning this circuit on. It shows some details about it. Here we have two options. The first one is manual, in which the farmer has to manually enter the amount of water to be supplied to the fields. And the second option is automatic, in which we have to set the name of the crop, the observation period, and based on our database, it calculates the amount of water to be required by the crops. Now I'm going to select the automatic mode here, and it shows the name of the various crops we can select. Now let's select maize, and here we have to enter the observation period. I'm entering 150, and now it is collecting data from the moisture and temperature sensors, and based on the database it will calculate the amount of water to be required by the crops. And now it has detected a low moisture content. Now it has started the water supply, and when the water content in the soil becomes accurate, it will stop the pump. This system is also very power efficient, as both the microcontrollers here go into sleep mode for 4 hours after supplying the water to the fields. After every 4 hours, they wake up and the whole procedure repeats again. This system is very useful because it is very low cost, hardly under 2 to 3,000, and it increases the yield of the crops because accurate amount of water is provided to them. And as we are not supplying any extra amount of water, thereby we are also conserving water in a very sustainable way for our futures.